Hello, so in this video we're going to talk through the quotient rule, okay? Now just remember, the quotient rule is just an extension of the product rule. It's literally just the product rule, just where you've got the denominator is just a power of -1, okay? So in fact, the quotient rule and product rule are pretty much the same thing. It's just quite handy to have a quotient rule for a situation where you're dividing two functions instead of multiplying them instead. Okay, so it basically says if I have two functions, so u and v, I'm dividing them by each other, okay, then the derivative of the quotient, presuming that u and v of course are functions of x, should be equal to v multiplied by the derivative of u minus u multiplied by the derivative of v, all divided by v squared. So let's have a look at some questions. Let's take, for example, y equals x squared plus 5, all divided by x to the 5 minus 2, okay? So if I want to differentiate this, I first of all need to identify what is u and what is v. Well, let's say the numerator is u and the denominator is v. Now, quick word of warning. When we're doing the product rule, it didn't matter what we called u and v because we're just multiplying two fractions. We'd end up adding them together in the final rule anyway, okay? So it didn't really matter what function we called u, what function we called v. With the quotient rule, it does. Because we're doing subtraction and because we're dividing by v squared, not u squared, it does matter what we call u and what we call v. So u has to be the numerator and v has to be the denominator. Okay, so we can't mix and match this notation. So let's say, well, okay, we've got u is equal to x to the power of 2 plus 5, which means the derivative of u, because we're going to need that, will just be equal to 2x. And then the denominator, well, we have v is equal to x to the 5 minus 2, which means the derivative of v is going to be 5x to the power 4, okay? Which means that when I stick these things into my formula, I end up with, well, dy by dx will be equal to, let's stick it in my formula. So I first of all get on the numerator v multiplied by the derivative of u. So v is x to the power 5 minus 2. Derivative of u is 2x. So I get 2x multiplied by all of this lot, okay? Then I minus u multiplied by the derivative of v. So u is equal to x to the power 2 plus 5, and the derivative of v is 5x to the power 4. Then in the denominator, I get v squared. So in other words, v is x to the power 5 minus 2, and I square that. So that's that there, okay? Now you could, if you wanted to, kind of go through, expand this out, see if there's any kind of factors which you can take out, simplify it down as much as possible. I am fine for you to leave it like this, okay? You've shown me what you need to for this question to get the full marks. All right, let's have a look at this one. So y is equal to the tan of x. Okay, so this one, you say, well, hang on a minute, this is not a quotient. I'm not dividing two things by each other. Except you are. Because if you remember the identity that tan of x is equal to sine of x divided by cosine of x, okay? And if you're not sure where that comes from, it's in one of the videos, so go back and have a look at that. It's just simply thinking about a triangle and labeling the sides up and thinking about tan is just equal to opposite divided by adjacent. Opposite is sine, adjacent is cosine, so therefore tan of x is sine divided by cosine, okay? So that means then that u has got to be equal to sine of x, that's my numerator, and v, my denominator, is equal to cosine of x. So let's have a look. Okay, so u is equal to sine of x, which means the derivative of u, think about your circle, sitting at sine of x, go round the circle clockwise, you go to cosine of x. That's the derivative of sine. Now, if I've got v is equal to cosine of x, sitting at cosine of x on my circle, go round the circle, I go down to negative sine to find the derivative of cosine of x. So now what I can do is actually fit this back into my formula. So I get dy by dx is equal to, well, just remember my formula, it's up here in case you've forgotten, it's a derivative of u multiplied by v, so the derivative of u in this case is cosine of x, multiplied by v, well, that's also cosine of x, minus the other way round, okay, so the derivative of v is equal to negative sine of x, I'm going to make that positive, so negative times negative is a positive, so negative sine of x, multiplied by u, which is just equal to sine of x. And in the denominator, I just get v squared. So v squared is going to be cosine of x all squared, which I'm going to write as cos squared of x. So now if I break this down slightly simpler, you notice that cosine times cosine is just cosine squared of x. And you notice as well that sine times sine is just equal to sine squared of x, all divided by cosine squared of x. Now, if you remember, on the numerator, I've got cos squared plus sine squared. Now, again, using those identities, similar to the identity I got for tan, if I do exactly the same identity and use Pythagoras, I realise that cosine squared plus sine squared is just equal to 1, okay? So therefore, on the numerator, I just get 1, and denominator, I've got cosine squared of x. Now, if I wanted to, I could leave my answer like that, but if you're comfortable with using reciprocal trigonometric functions, 1 over cos is the same as sec. Okay, so secant. So therefore this thing, the derivative of tan of x, is sec squared of x. Okay? So let's have a look at another quotient function. So let's have a look at something like this. So y is equal to e to the power of x squared, all divided by x to the power 4 minus 5x plus 3. Okay, so let's have a think about that. On the numerator, I've got u, so that's equal to e to the power of x squared. Okay, and denominator, I get v, which is x to the 4 minus 5x plus 3. Okay, fantastic. So that means then, if I want to find dy by dx, then I'm going to first of all have to find the derivative of u. So derivative of u is a bit of a chain rule function going on. So let's have a look at this. E to the power of something is just e to the power of something. So let me write down properly. Derivative of u is equal to, well, e to the power of something is e to the power of something, so e to the x squared, multiplied by that power, so the derivative of x squared, that's going to be 2x. Now, if I do the same with derivative of v, that's nice and easy. It's just a straightforward polynomial. So derivative of v should be 4x cubed minus 5. All right, so now if I stick it back into my formula, I first of all get the derivative of u, which is 2x e to the power of x squared, multiplied by v, which is equal to x to the 4 minus 5x plus 3, minus the other way round, so u multiplied by the derivative of v, so I get 4x cubed minus 5 times the u, which is equal to e to the power of x squared, and if I divide all of that by v squared, well, okay, v squared is going to be x to the 4 minus 5x plus 3 all squared. Now you could, if you wanted to, go through and simplify that. Notice the fact you can pull out an e to the power of x squared, and then everything else will just kind of cancel down quite nicely. There are a few terms which I probably could cancel. I'm going to leave it like that just for the sake of time. Okay. Now finally, let's have a look at this one. So y is equal to x to the 5 plus 8x, all multiplied by the tan of x to the power 4, all divided by e to the power of natural log of the cosine of 3x minus 5. All right, so it's a bit of a long one, but let's break it down, okay? So here I'm going to call u, I'm going to call that x to the 5 plus 8x, okay? And now v is, multiply all that, of course, I can't just get away with that. Multiply by the tan of x to the power 4, okay? And then my v on the denominator, that's going to be equal to e to the natural log of cosine of my 3x minus 5. Now the thing is, I'm laughing. I'm laughing because actually I know how to deal with this. This is just basically using the stuff we've already looked at before. It just needs to keep my wits about me. So I need to make sure that I write as much as possible down to make sure I don't make mistakes. So let's have a look at u first of all. So I need to find the derivative of u. I need to find the derivative of this thing, the x to the power 5 plus 8x times by the tan of x to the power 4. Well, let's first of all think about this. This is just the product rule because I'm multiplying two functions by each other. So if I differentiate the first function, I get 5x to the power 4 plus 8. So my first function is 5x to the power 4 plus 8 differentiated. And I leave my second function alone, so my tan of x to the power 4. Then I need to add that to the other way round. So I leave my first function alone, which is just x to the power 5 plus 8x. But then if I multiply by the derivative of tan, well, we've just seen the derivative of tan is just sec squared. Okay, so I get sec squared. And I leave my inside function alone, so my x to the power 4. Then I need to multiply that by the derivative of my inside function, which is 4x cubed. Okay, so that's the derivative of u. Let's think about the derivative of v. Well, derivative of v is just going to be, well, it's e to the power of something, so I'm going to write that as e to the power of something, so e to the natural log of cosine of 3x minus 5, okay? Now, if you're comfortable with e's and natural log powers, then you might be able to see a shortcut, but just for the sake of simplicity, I'm going to leave it like this. And then you need to multiply by the inside function, so they multiply by the derivative of the natural log of cosine of 3x minus 5. Well, the derivative of natural log is just 1 over, so it's going to be 1 over the cosine of 3x minus 5. Then I need to multiply that by the derivative of cosine of 3x minus 5. Derivative of cosine is negative sine, so actually I'm going to stick the negative right out the very front and I don't have to worry about brackets or anything. So it's going to be the sine, leave the 3x minus 5 alone. And then finally, I'm going to multiply by the derivative of 3x minus 5, which of course is just 3. So again, I'm actually going to stick the 3 out the front here, so I don't have to worry about putting brackets in. It just makes it look a bit nicer. Now I'm in a position where I can actually find the quotient, so it's the derivative of my quotient. So dy by dx should be equal to, so let's have a think, derivative of u is just all of this thing here. So I'm actually just going to literally copy and paste. And I'm going to keep the colour coding just so it's easier for you to see where this has come from. So this is my derivative of u here, okay? So that's my derivative of u, okay? I then need to multiply that by the derivative of v, so I'll put that in a big bracket, okay? I need to multiply all that by the derivative of v, so again, I'm going to take this, I'm going to copy it, and I'm going to put it in a bracket down here, and I'll paste it down there. Okay, so that is my u multiplied by the derivative of v. In fact, no, I don't want to multiply the derivative of v, do I? I'm getting ahead of myself. It's the derivative of u multiplied by v first of all. So that is my derivative of u. Let's go back a step. There's my derivative of u. I then need to multiply by v. I forgot the formula. I got overexcited. So there is my v. Okay, so I'll copy this down for you and stick it in there. Okay, so there's my derivative of u multiplied by v. I then need to take away, well, I need to now take away the derivative of v, which is this thing here. Now, of course, you notice that the derivative of v already has a negative in there. So I effectively get negative, and then I take it away again. So a negative, negative, that effectively just becomes a positive. So I'll end up adding that, okay? Then I need to multiply that by, and I think I've lost a fraction here maybe. Nope, it's just 1 over, okay. So when I copied it, it didn't quite copy down. It's shouting at me. So there we go. So that's the derivative of v. I then need to multiply that by u. So let's have a look. What was u again? Just remind me. In fact, I'm going to bring this down because it doesn't look quite right. There we go. So what was my u again? So my u was all the way up here. It's quite long and messy, but that's fine. So I'll copy that down and I'll put this here as well. Okay. So there we go. I'll paste that in. Like so. Okay, the advantage of copy and paste. Let's zoom out so we can kind of see what's happening here. Put all of that big long horrible thing over a over vinculum, so I put it over a denominator, and the denominator is going to be v squared. So again, I'll take my v, which is this thing here, the x to the power, not that one thing there, I'm getting. Okay, it's the e to the power, the natural log of cosine of 3x minus 5, and I'm going to stick that on the denominator. And then I'm effectively going to square all of that, okay? So what I'm trying to show you there is that even though it got a bit in the weeds, like we got a little bit in sort of, you know, really in depth with things like chain rule and product rule within like the quotient rule question, the point is if you just follow through your nose and just follow it through systematically, then effectively you just end up with this. This is no different to the other questions I'm doing, it's just it's more involved because I'm having to do more differentiation along the way.